In this particular unit, we're going to take a little bit of a break from algebra, and we are going to spend a little time studying trigonometry. This will be very useful for you as you start to prepare for the ACT. There are only 4 questions on the ACT regarding trigonometry, and we will cover probably 99.9% of anything that you could see from a trig standpoint on the ACT. So this is a very timely unit, and a lot of it will be very familiar to you as information that you learned in your geometry class. So these first few lessons will go a little quickly. Should be a very nice review for you, and I would expect you to work through these very comfortably. So as we get started, we really get started in trig with right triangle trig. Now, as we'll see later in the unit, there are other methods of trigonometry, but the simplest place to start is with right triangles, and the reason is because of what you learn to do in geometry with your right triangles. And you can see here what you probably remember from trig is sine, cosine, and tangent, and those ratios were actually set up as a result of the angle-angle similarity postulate. Now, if you recall, similar triangles are triangles that have congruent angles but proportional sides. And so the sides of these 3 particular triangles are proportional to each other according to the given angle, and that angle is congruent in all 3 triangles. So that's where the trig ratios that you learned in geometry actually come into play. Now, a couple things that we need to learn or remember from geometry are the parts of a right triangle. We have the 2 legs, if you will, or the sides, and then we have the hypotenuse of a right triangle. We'll kind of change those terms in relation to a given angle. Now, one thing that I want you to become familiar with are Greek letters. No longer will we use X's and Y's to represent angles, but we'll use Greek letters. And so what I've done, and which will be good for you, is I've pulled up here the list of Greek letters. This is the Greek alphabet. Now, I'm not asking you to memorize these. I just am going to point out a few that will be used on a regular basis, such as alpha, beta. You've already seen delta. Theta is used a lot for angles. Mu, obviously you may recognize that from mu alpha theta. That's used a lot for the mean in statistics. Pi, which you've already seen. Phi will be used quite a bit. And so these are different Greek symbols or Greek letters that will be used as variables, if you will, very similar to A, B, C, and X, Y, Z. So I don't want you to be thrown off by those. They're just representing a measurement, and it's just a matter of recognizing what they are and what they mean. So the most common one that we'll probably use to represent an angle measure will be theta. And so you can see here we have theta in this given drawing, and in relation to theta we have what we would consider the opposite side, which will be the leg on the complete opposite side. We have the adjacent side, and of course the hypotenuse always stays the same. Now we need to know these parts to define our 6 trig ratios, or our 6 trigonometric functions. Now, last year you probably learned sine, cosine, and tangent. This year we're going to learn the reciprocal functions. And so if you remember the reciprocals, just flipping the ratio, cosecant, secant, and cotangent. So learn how to pronounce those and learn their abbreviations. That's how you're going to see them. So that's a good start, good introduction. Now we have here a little table for you, kind of keep you on track here. Now, last year you may have learned a little acronym, SOHCAHTOA, to remember that the sine is the opposite side over the hypotenuse, the cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. Now what you'll need to learn are the reciprocals of those. Most importantly, you need to know that cosecant goes with sine, secant goes with cosine, and then cotangent goes with tangent. So it's very important that you understand which ones are reciprocals of each other, because we'll be using that in a number of different ways to solve trigonometric problems. Okay, let's take a look at our first example that we have here. And this is very much a repeat or a review of what you did last year. So if you look at this, it says evaluate the 6 trig functions. First and foremost, if you remember, evaluate always kind of meant to substitute something in there or to find the value of the given information. Well, evaluating the 6 trig functions basically means to set up the 6 trig functions. All we want you to do is to get the fractional value that represents the sine, the cosine, and the tangent. Now, with the diagram that's given to us, we actually have a missing side. We have a missing side of the hypotenuse. So you remember from the Pythagorean theorem, we have c squared equals a squared plus b squared. Now, one of the things that you're probably going to want to learn and remember is something called a Pythagorean triple. And if we worked out this particular Pythagorean theorem, you see that we get 5. So we actually have a 3, a 4, and then a 5 for the hypotenuse. This is what we call a Pythagorean triple. 3 whole numbers that fit the Pythagorean theorem perfectly. And remember, they have to be whole numbers because they have to be positive since they represent lengths of a triangle. Now, the more Pythagorean triples you know, the faster this part of the process will actually go. Now that we have all 3 sides, we can actually just fit into SOHCAHTOA and just replace the opposites in the hypotenuse and so forth in relation to the angle theta. And so you can see the answer here below. We have sine, cosine, tangent, and then we have the reciprocal functions of cosecant, secant, and cotangent. So when we ask you to evaluate the 6 trig functions, this is all we're looking for. We're just looking for you to set up the 6 trig functions. We're not asking you to solve for anything at this point. All right, let's see if we can use that for sample problem 1. So go ahead and work sample problem 1. Just evaluate the 6 trig functions, and then stop right there and come back and watch the solution. Okay, first thing I need to do is find the hypotenuse. So I need to start with the Pythagorean theorem. And we have a squared plus 15 squared. And if you work this out in your calculator, you'll see that the hypotenuse is 17. This is also a Pythagorean triple with 8, 15, and 17. Notice when I'm writing this Pythagorean triple, it's A, B, and then C with the hypotenuse always coming last. Whenever you see a Pythagorean triple, that's what the form that it will look like. Okay, so the problem asks us to evaluate the 6 trig functions. So evaluate simply is asking me to set up the 6 trig functions. So that's what I'm going to do. I'm not going to solve anything. I'm just going to set up the ratios. So you can see here I've set up the first 3 that you probably remember from SOHCAHTOA. Sine is opposite over hypotenuse, cosine, and then tangent. Now it asks for 6, so I need the reciprocal ones as well. So I'm going to go ahead and do the reciprocal functions also. Okay, so you can see the reciprocal functions there. Now, let me point out a couple things. So when you see this on a unit test, there's a couple things that I will be looking for here. If I ask you to evaluate the 6 trig functions, this is all I want, are the trig ratios set up. Secondly, if you do not put the angle in there, it is incorrect. So make sure that you do that. If the ratio can be reduced, so we have 8 over 17, if that could be reduced, you would want to reduce that. In this case, we don't have any reducible fractions, so we'll just leave them like that. Later on, we're going to learn how to actually solve for the angle theta. So you don't want to confuse evaluating the 6 trig functions versus solving for the angle. So a lot of students have missed a lot of easy points on the unit test like that in the past. So a couple things to be aware of. Alright, we'll stop right here and come back in the next video.